So I stare at this pipe. I had so many hours staring at this pipe. It's been 4 years. There's no need for the pipe. Magnetic current. No need for the pipe if he wasn't doing something with it. And I believe he was. The pipe is critical. V-shaped magnet. Pretty heavy. Compared to neodymiums, not all that strong, but they do have some strength. And just not like the neodymium, but they do have strength. Just a magnet. But one thing special that makes this magnet special is that it's V-shaped. It's designed to deliver the North and South Pole side by side versus like a bar magnet or horseshoe magnet does. But it's not designed to create power or anything. These were designed to create electric in the Model T Fords, like in the 1906 to 1914, till they figured out they can make an alternator and do away with this. It wasn't all that great, so, but it got it started. It got the process started. So, for you guys that don't know, or girls, that Ed Spider Huff was the chief electrical engineer for Henry Ford. Him and Henry Ford were close. And Edward Spider Huff, he was pretty remarkable in his work, but he also was a tough guy. He used to go to brothels, and Henry Ford used to have to send his henchmen over there to pull him out because he would be disappearing for a length of time, and things were going on at the electrical engineering shop for a Ford, and he was supposed to answer back, and he couldn't find him, and he always would find him in the brothels. True story. Ed Spider Huff, when he retired to Homestead. So if that rings a bell for anybody that is concerned about Edward-Leedskalnin and these V-shaped magnets, and of course he had the junkyard not too far away, so he was able to, there was a lot of these around. The fact that they are magnets, you know, I'm sure he could have got his handful, 120 of them. It's a lot of magnets, and the Model T Ford only used 16. And it got about 26 to 28 volts with good current. So the good thing is, you know, as the RPMs go, it's generating good current just idling at 1200, 900 RPMs. So they're capable of, you know, 26 volts. You know, it's some good power. But, you know, you have to turn it, and, you know, there's going to be resistance on it, so it'd be hard to turn as you put a draw on there, or you put a load, or light a light bulb, or a motor, or something. So, and Ed didn't show that he had much electrical stuff down there. I've been down there several times, and many times, and tore the place up. And there's no electrical devices. But, you know, what did they have back in that day? You know, they had things, you know, but nothing. So what would he use electric for? I did work at night. They said he worked at night, so basically for lighting, you know. I did look on top of the perimeter of his wall, and he had round hooks in there. Not hooks, but all round eye hooks all the way around. So I heard a story that he cabled wire and made a grid, and everything had, you could tap into it and have electric anywhere you wanted. So he must have had grinders, and must have had chisels and stuff to do his artwork, you know what I mean, with the grinding and all that stuff. As far as him using the wheel for a grinder, you know, it's creative, but I don't buy it. But back to the pipe. The pipe is critical. The pipe don't need to be here to demonstrate some electrical things, or don't even need to be there to do anything with. If you want to say this does something, and say it was a, you're saying it was a, you know, it did something besides make electric, then the pipe still don't need to be there. But the pipe's there. The pipe's at his place. He's got that long coil that I took off the wall and put it down the pipe, and matches perfect. So I think I found a home for it. Got me thinking. So if you guys ever hear that song by Bob Ross, the remix, it's layer after layer after layer, Happy Little Clouds. What I'm noticing is that if you have a magnet in front of the iron and you present this tension, because right now the magnet wants to pull itself to the iron, the copper will react behind the iron. And then behind the copper is the iron core there. So where you would have a density of saturation and a oscillation, I guess you would say, between the center core iron and its outside iron, and the copper being in the middle. So what I'm thinking about is putting more layers into the pipe to create I got to go back to the element chart, because it's the element chart of layers of different metals that is what I'm going after here. It's more of a static induction using magnets to drive, because in one of my videos, if you guys looked at, I took a damn electric motor, put a rubber band on it, and then put a pulley on the end. I spun the rubber band around, and I put a metal pickup with a point on one end and a metal pickup the other end, and I put a load of those two, like a cardboard, and that cardboard became a load to those two. So one side picked its own to be a positive, one picked to be a negative. Outside that cardboard, when you would come up to your hair or stuff, it would static and stick to the cardboard. That's because it's a transfer of energy that's coming from there. And that's sort of what I'm leaning towards. Ed, in his writings, talks about it. He talks about the magnets and everything. And you know, he's talking about so many different parts, you know. And you have to open your mind and think, this is more than an electrical generator. He made a patent. I can't find the patent. Nobody can find the patent. And if a patent was filed but never being a patent, then probably they don't keep that files anyway. So why in 1940, okay, if you're going to make a patent, you make a patent on a generator? Maybe. But there's a lot of generators out back then, so I don't think this was special just to be a generator. Plus, it doesn't make anything more. Well, this, with the coil set up like the Model T did, it would make 26 to 28 volts, I'm pretty sure, times 5 layers. So that would be almost 110 volts of DC. Yeah, that'll rock and shake something up. But that's yet to be seen until somebody builds one with a set of ring coils that went around the whole top is fixed. So when this turn, they're going past those. They were like ribbon copper real thick, about 4 or 5 turns, and with a center stud, metal stud, and then they were all connected together, and that was the coil system for the Model T. Back to the pipe. So I'm into this thing. I'm staring at this thing, and I'm thinking about it. It's more about the ground. See, it goes down like 8 feet and 8 feet, something like that, and it's all about the ground. The ground, like the planet's surface, is mostly made of glass, crystal, glass, silica, and it's 96%, 4% inert metals, your irons, and yada yada yada, aluminum and a powder flake. Now, think about that. That is the surface covering the Earth, and that's attracting the energy that's coming in from the sun. It's also attracting the energy. Coming from the sun, going through the matter back to the center, if everything's being absorbed to the center core, which I don't believe it's molten iron. I believe it's hollow. And then iron around it, like water does when you put a bubble in the water. You'll have a hollow space, but a round sphere of pressure all around it. I believe the Earth in the center is just like that. And then you have your molten metal, then you have your metal core, iron core around it, then you got your material from there on. Anyway, not my job. Back to the metal. So we're trying to transfer and do, we're trying to do a conversion. So we were trying to move the negative energy in the material. Positives fixed, okay? And the neutrals with the positives somewhere in the center of every atom inside this material, or any material. So everything has the same characteristics of being able to hold a charge and has motion inside of it, even though it's still, okay? Well, the proton is still, but it's a positive energy. And then you got your negative energy orbiting on the outside of it, and your neutral stays in the center along with it. So if we're going to go after moving the negative energy away, because we can share the energy in between all matter, which is the negative side, so we can pull that energy to one side of this material, and without touching it, and have this induction between that and the matter next to it, and that's the magnet. So forth, the magnet is the start of the process, because it's got the energy already built up in it, so we don't have to add energy to the system. What we would be doing is taking this, running it by iron, running it by copper, iron core. This is how you get your basic electric, but we could, in a sense, step it up in voltage by using materials like a Wimshurst would use, which is dielectric materials. And with these dielectric materials, we'll be incorporating the traditional, here's your low current, low voltage input from what the coil, or it'll have some, don't get me wrong, right? Low meaning if I'm going after the other stuff with the dielectrics, will be able to give me the static, which is the high voltage. There's a pressure down that you go with that high voltage to where you get down to the medium of 110 volts, or just stuff that don't kill us, 50 volts or whatever down on. But these are the start of that. I'm going to